Good morning and welcome to the RightScale webinar, Cloud Computing Basics. Before we get started, we're going to ask you a couple questions. We use the answers to these questions to help tailor our presentation, and actually it's also really useful for us for market research. So let's go ahead and load up the first question. You should see it coming up on your screen. So we'd like to know, are you using the cloud today? You can answer yes, very much. You have several projects in the cloud. You have a project right now that's evolving with some importance. You're just beginning to explore, or no, you're not. So what we're seeing right now is that people are just beginning to explore the cloud. So that's great. I mean, this is a Cloud Computing Basics webinar, so it makes sense that you're in that phase. So let's get up the next question. Why are you considering cloud computing? Are you looking to save costs, increase agility, IT or business? Are you looking to access additional computing resources? So this one you can actually select any that apply. I'll give a couple more seconds for people to respond. And it looks like actually it's pretty evenly spread across the board. People are looking to do all of these, which also makes a lot of sense. So our final question is actually two questions with just multiple answers across them. So the first half, what are you looking for in a cloud management platform? So again here, just select all that apply. Reducing complexity, you're looking to get onto the cloud quickly. You're looking for help with configuration management, automation, or management of multiple systems, which are groups of servers. Leave this open for a couple more seconds. Again, spread across the board. You're looking to do all of these things with reducing complexity and automation at the top of the list. And the second half of this question is coming up. Same thing here. What would you like in a cloud management platform? User management or cost management? The ability to implement a unique architecture? Or the ability to choose a software stack, database, and other system components? Or the ability to choose your cloud infrastructure? Excellent. Spread across the board again with just highlights on the ability to have more customized management. I like you guys. This is great. Okay, cool. So we're done with the polls. Thanks for your patience in answering our questions. And let's get started. I have here with me Michael Crandell. He's one of the founders and also the CEO of RightScale. I also have with me Yuri Budnik. He's RightScale's evangelist, and maybe some of you have seen Yuri in the flesh. He actually travels all around the world talking about the cloud, talking about RightScale, and educating people about the two. Online and ready to answer your questions are Andrew DeMille and Bryce Larson. You'll notice if you look in the GoToWebinar control panel that there's a questions pane. Feel free, like throughout the course of the webinar, type in your questions. Andy and Bryce will be answering those throughout the course of the webinar, and we'll actually consolidate the ones that are more generally applicable and address those during a live Q&A at the end of the webinar. So again, anytime anything comes up that you want to know more about, we're all looking at these questions, we'll pull them up, and we'll make sure you get an answer. You can also feel free to join us on Twitter. Follow us. We're just simply RightScale, and we're using the hashtag CCBasics. Michael and Yuri are also on Twitter, and their names are here. It's just their full name. So here is our agenda. After a very brief introduction to who we are, Michael's going to talk about what is cloud computing and focus on who's using the cloud and what they're using the cloud for. And then Yuri's going to give us a full demo of a few projects that are ideal for first getting started on the cloud. Then we'll share some thoughts and resources with you on how you can promote a project in the cloud with your internal colleagues. And at the very end, we'll have a very live Q&A. So, Michael, I'll turn it over to you.
Thanks, Sarah. So, welcome also, Yuri.
Thank you, Michael.
Welcome, everybody, to the webinar. Let's dive right in. Just a word about who RightScale is before we start. RightScale is in the cloud management business. We're a broad-based platform delivered as a web service, so through a web browser, that allows you as the companies to manage your resources, whether they're in public or private clouds, remotely, wherever they are, with full automation, control, and portability across different cloud environments. We've garnered over more than 25,000 users on our platform, launched more than 1,400,000 servers, and powered some of the biggest scaling events that have happened to date in the cloud. You see some of the references here, as well as running very large steady-state production deployments for customers. And that's one of the reasons we're bold enough, I'd say, to take the moniker No Hype for our user conferences, because RightScale has really focused on those who are interested in deploying something in the cloud today, whether it's development and test or production. So just a very quick review for those of you who are brand new to the cloud. What is cloud computing? Well, it's really about some key characteristics. It's about flexible computing resources. Originally, these were thought to be usually in outsourced hosted data centers, and hence the original diagrams that showed network traffic going between one location geographically and another and passing through the internet was usually drawn as a cloud because the routing and the actual direction of the traffic isn't always known. But now clouds are also being deployed on internal data centers. So really the key here is flexibility in allocation of compute resources, which is initiated by the ability to allocate these resources on demand and then pay for them as you go if it's an outsourced provider. So all of this is available over the internet through a web browser, whether it exists, again, in a hosted data center or inside your own enterprise data center. The other key characteristic of the cloud is around benefits, and in particular, agility. So when we talk about business agility, we're talking about the ability to launch projects quickly and get them up and running for your customers, whether they're, again, outside your company or business users inside your company, with much more agility than typically has characterized IT projects. There's also substantial cost reduction that's often available, and through the cloud, significant increases in reliability and freedom of choice.
And Michael, this really solves a classic IT problem, which is how to allocate resources, how to provision infrastructure. And there's something I want to cover on this slide. I know there's a lot going on here, so bear with me for a moment as I explain what's going on. I would like to call your attention first to the gray dotted line across the middle. When you're planning an IT project, you've got to make a decision about how much infrastructure to provision for that. And usually it goes up over time. That's what you're seeing on your X and Y axis, the cost and the time. But that's not exactly how you buy the equipment. You buy that in big lumps. That's why the blue line has that stair-step shape. And you try to stay above whatever your predicted consumption of those resources is, the number of servers you will have, but you buy them in kind of a lumpy way. But the actual demand on the infrastructure, it's almost impossible to predict. Anybody that's ever worked on this will tell you that. Taking a guess almost guarantees that it will be under or over, but there's no way that you can hit that right. So what most companies do is they weigh over provision capacity. What you see there with the red line is the actual consumption on resources on this hypothetical example, and notice that it both goes above and below what you originally forecasted. So what I'm showing here with the green line is what I just said a moment ago that a lot of companies do. They weigh over provision capacity, and economists call this an opportunity cost to denote that you could have done something else with that capital that you dedicated to servers that are mostly sitting there idle just in case somebody's using them. And you do that to avoid a situation like what you see in the red shaded area, where the red line, the actual consumption in your system, is above the capacity at that time. So in a public-facing website, think of your servers either slowing down or completely halting, stopping, and not being able to respond to requests, and your site being unavailable. And that's a quick summary. I know everybody on this website is probably already somewhat aware of how cloud computing works. This could be something you use internally to explain to other people the benefits of this flexibility that cloud computing brings, which is what you see on this diagram here. The red line is still the actual demand, as I said a moment ago, but what Michael was explaining about being able to provision and allocate resources on demand is what you see on the yellow line here, being able to closely follow that demand at that moment. And notice the line both goes up, but it also comes down. Anybody with a big enough budget and a big enough data center can just keep adding equipment, but the idea is that you release resources when you're not using them. That's why, and by releasing them, by the way, you're not paying for them because it's pay per use. So it makes it more efficient in many different dimensions. I'd like to address now a couple of things about cloud computing and what people mean when they say that, because sometimes they can mean significantly different things. Software as a service, platform as a service, or infrastructure as a service all get classified as cloud computing, and that's what you're seeing on this graph here. And also notice the X and Y axis show a trade-off between automation and lock-in or portability. So software as a service, we actually know this for quite a long time. It also gets categorized within cloud computing. So Yahoo Mail has existed for many, many years, and now people think of it as cloud computing. Any software that you're running through your web browser, you can think of it as software as a service. Very little to configure, almost nothing, but also very little flexibility in how you might use it. Moving along here towards the right, we have platform as a service. Think of that as a code execution environment. Now you can run your own programs with your own business logic that you design, but because it's a platform, you're not in direct control of the machines themselves, the servers, the operating systems, the IP networks is not something that you have to contend with, so you have more flexibility, but you're shielded from some of that complexity. Again, that trade-off that I'm describing there. An example is the Google App Engine, where you can upload your Python code to run it there, or Salesforce has a platform called Force.com where you can write applications on Apex. And moving along towards the right, you have infrastructure as a service. What you have here is the building blocks that you know and you use today. Servers, storage, the IP networks that connect them. So you can build your systems the way you would do them today, but you don't actually have to run the physical plant, the infrastructure. That's what you're getting from the infrastructure as a service provider. And what we do at RightScale is we bridge that gap by providing a lot of the automation that you'll see in a demonstration in a little bit, where you still have us taking care of all this heavy lifting that it takes to build actual production environments from basic servers, but you still have the ability to customize and to tweak and to configure anything as you may. And that's the part where we add a lot of value. We don't ask you to compromise between having complete control and delivering a large amount of automation to the systems that you want to build, both in the original provisioning and also in the ongoing management. And another really interesting value that we bring to the table is the idea of multi-cloud. You can build something in one provider that is then possible to move to a different one, whether it's another public cloud or maybe a data center that you build in this cloud style of provisioning using Eucalyptus or another of our partners that deliver this kind of technology.
Right, you know, the net effect of all this, Yuri, is what we see on this graph, which is that cloud itself, infrastructure clouds and managed infrastructure clouds, to be direct using RightScale, have seen tremendous growth in consumption. So this is a graph showing actual cloud usage of low-level infrastructure resources. Let me go back a slide. It was really a growth of 1,000% month over month for over 12 months, year over year, from summer 2009 to summer 2010. So massive increase. Where's that coming from? Well, we see that people are running more servers, of course, but they're running larger servers. As you can see in this diagram, the trend from March 2009 through June 2010, the types of servers that are being run, and by the way, in the cloud today you have a wide choice of servers from sort of single core, 2 gigabyte, up to 16, 32 core, many, many gigabytes of memory, etc., and variations therein. So they're running more servers, servers that cost more, and they're running them longer. And as an end result, the consumption has really increased. So this is a very, very powerful disruptive force in the way people are utilizing IT. We wanted to cover a little bit before we dive into the actual demo and then give you some tools for how you can analyze cost and utility of this kind of new cloud computing and promote it inside your organization. A little overview of who's using cloud today. So this is a map of RightScale users, RightScale customers. What we discovered, a little bit of a surprise to us, is how fast cloud computing spread globally. So you can see from these white dots that really our customers span the globe. And part of the reason for that is the ease of access to data center resources through a web browser. So you can be, for example, in Nigeria or in Israel running data center resources in the east coast of the US. But today there are also cloud locations across most major continents on both coasts of the US and in between, in Asia, in Europe, etc. Cloud infrastructure data centers are everywhere now, and you can control them from almost anywhere. So it's a pretty unprecedented situation in terms of the benefits of flexibility and the power of the control that you can get. But let's step through who's actually using cloud computing on RightScale. So we really span companies from Web 2.0 to enterprise with many different use cases. The equivalent of our kind of A to Z in customers is AstraZeneca, which is, you might know, is a biopharma company, to Zynga, which is famous for their Facebook games, and many, many different vertical industries listed here in between. We also have a number of what we see as ideal use cases that are really very what we'd call low-hanging fruit in terms of projects that can get up and running very quickly and are ideal for the cloud. They range from scalable websites, any kind of social app or social game, grid applications that run large batches of processing of the same type of task over and over, development and test, disaster recovery, where a company may want to position a small footprint of resources in a cloud that can complement another cloud or can complement an internal system that they can then spin up and scale up very quickly. And all of this is around, in general, application delivery. And it's also being used heavily for app delivery inside enterprises of a variety of kinds, often collaboration apps, wikis, SharePoint, things like that. So let me go through quickly just some examples. Sony Music is one customer that's using RightScale, and what they use it for is to power their artist sites. Really two sides to the artist sites. Here you see some examples of just really fan destination sites where fans can go to find out what's going on with some of the musical artists, but also the e-commerce sites that go along with these where CDs and amps and LPs and so on, and paraphernalia, branded stuff is sold along with the artist site. And those both are run together. It's a popular app for Sony because on the cloud because they're not always sure which artist is suddenly going to gain notoriety or popularity due to some external event. So they're happy cloud customers. Here's another example. It's a company many of you know called Sling Media. And Sling Media is in the business of allowing you to watch TV content and media content that you've subscribed to anywhere that you take their Sling box. And so they're really pushing content that you've subscribed to many different devices, as you see in this diagram. They use the cloud and RightScale to do grid processing of transcoding this media. So they get the media from many different publishers, like the publishers on the left. They have to push it into different formats that are appropriate for everything from a big screen TV to a mobile phone, for example, so that the shows are ready to watch when you as a customer want to watch them. Another example is a customer of ours called StarCut. StarCut powers mobile stock quotes for one of the big stock publishers. And what you see here is an actual RightScale monitoring diagram that shows the traffic that they get. It's a very repeatable pattern. People check their stock quotes in the morning, tapers off a little at lunch, and then again in the afternoon. And then they stop checking basically in the evenings and the weekends. So StarCut uses a function we have called scheduled scaling that fires up additional resources around these peaks and then releases the resources when they're not needed. So they're basically saving money but also providing an optimum user experience in terms of the responsiveness of the site when people do visit it. Facebook application and games has been a big area for RightScale, and really RightScale powers, this data is from last April, but I think it's largely still true, We power the top 10 applications on Facebook that are not provided by Facebook itself, and many of the leading providers that aren't Facebook itself, as you can see on the right there. Here's another example, recent customer of ours that launched the American Girl doll series online world called InterStarUniversity.com in the cloud. They got this done extremely quickly with still the ability to meet whatever demand came when they've promoted this new social networking world that's available for customers of American Girl. So that was a very exciting project, very colorful website, and very successful also. And the final example I wanted to share is from a biopharma company, Eli Lilly, and their utilization of cloud and RightScale is a more traditional enterprise application, but they've taken it a step further. So in addition to building wikis, collaboration apps, grid processing, where a researcher at Lilly can fire up a grid easily and quickly to do, for example, protein analysis, they've gone a step further and in cooperation with us built what we call a self-service portal to the applications that they enabled and designed on the cloud through RightScale. And this lets their IT department have full control over the design of applications so they can make sure they're compliant and they have governance over that and so on, and that they're built according to best practices as Lilly sees that, and then deliver them in a simpler vending machine style interface to their business users. So the business users can go in and pick from 4 or 5 different applications. And Lilly talks about reducing the delivery time from 30,000 minutes, which is something on the order of 5 weeks, to 30 minutes. So again, returning to that theme that we talked about initially of business agility through cloud computing. So now I'd like to pass off to Yuri, and what we're going to do is there are many, many use cases that are enabled on RightScale, but we decided to pick 3 that are fairly common, but also different. And Yuri will walk you through how one might use RightScale's prepackaged cloud-ready solution pack for building a scalable website, and then for building a grid for batch processing, and finally for an easy way to fire up a dev and test environment across one of 4 different programming languages. Actually walk you through what that looks like in the RightScale interface. Yuri?
Thank you, Michael. And I've been monitoring the questions as they're coming in through the chat feature and GoToWebinar. I'd like to take the opportunity to answer a couple that fit right into what I'm going to do here for the demo. Somebody was asking whether RightScale offers software as a service, platform as a service, or just infrastructure as a service. And that's why I wanted to describe that in the beginning, that people mean different things when they talk about cloud computing. RightScale is software. So it happens to be software as a service in the sense that you're going to see me right now running it through the web browser. In fact, let me switch to that right now. This is, and I'll start the demonstration in a moment, I'm controlling a bunch of servers through my web browser, but we connect to the infrastructure as a service providers. Companies like Amazon Web Services that has an offering called EC2, the Elastic Compute Cloud, they literally rent you servers by the hour. And you're going to see me doing this right now, make it easier and faster to build the environments, your systems running on them, and to do the ongoing management. And that also dovetails into somebody asking whether we have cloud infrastructure ourselves in India. We connect to the providers that offer the infrastructure as a service to help you build the environments. So let me get into that right now. The first example is for the scalable photo site, and I'll start just by describing what you're looking at. I'm logged into an account we use for demos, that I call here the demo site, and this is the dashboard view of RightScale. And I'm going to scroll down a little bit and describe this concept that we have of deployments. A deployment is a group of servers that I can manage as a unit. And what you see here is all the different deployments that I've created in this particular account, and the colored dots on the right shows you what's running and what isn't. And deployments allow you to organize things, and also makes it a lot easier to understand what's going on, and compare and contrast that to just having a long alphabetical list of server IDs when you don't know what's going on in any particular environment. So it's a lot easier to actually get a bird's eye view of what's happening this way. Now this scalable photo side, I'm going to start with that. And in cooking show style, I already have a bunch of tabs open with the different things I want to show you. So by clicking on this particular deployment, I get an information page for the deployment itself. And that's what you are looking at here. Collection of servers, they're running in different clouds. And I want to call your attention here to the section at the bottom where from choosing from this drop-down menu, I can quite literally add servers to this deployment that I can manage together that are running in Asia, in Europe, in the US East or West region, all of Amazon Web Services clouds from a different provider from Rackspace. And if I had my own private cloud that I had connected into this particular RightScale account, I would see it listed here too. So single pane of glass to manage not just multiple servers, but multiple servers in multiple continents, potentially from multiple infrastructure as a service providers. Now what we're looking at here, let me show you a quick logical diagram of what this is. It's meant to be a very simple, modest architecture here. Just a couple of web servers talking to a master-slave database, and that's exactly what we are looking at. Oops, I meant to pick this tab. The two front-end servers talking to the master-slave database. Now, during the explanation from Michael, we were talking about auto-scaling, and we were approaching it from the theoretical aspect of things. Let me actually put it into practice now, how that actually takes place. So imagine these are your two web servers, app servers, and they're receiving more traffic than they can handle at this particular moment. And we talked about auto-scaling. The way that happens is we have this ability to auto-provision more machines based on the load that's taking place at that moment. And by the way, it's not just standing up another virtual server. That's half the job, and that's the easy half of the job at that. It's, as that happens, auto-configuring this machine so that it knows what database to connect to, and then telling the load balancer that there's an additional resource that it can put into the load balance pool and pass traffic onto it. That's really the magic of the full automation and how it happens in RightScale. And this is done via setting up a particular trigger point. We call it an alert, but you essentially tell your environment, if these two servers are busy being defined specifically for what your application needs and it means in your context, then provision more servers for me. So switching back to the UI, we're looking here at a collection of servers, my two front ends that I've been using the example. If I click on one of these front ends, front end A, once again I have my tab already open here with the information, and this is the monitoring. Let me scroll up so you can see. It says server, front end A, as I just mentioned, and I have a lot of tabs for all the information that I can look at for the server, and I'm looking at the monitoring tab, and I happen to be looking at the CPU load. And you'll notice it's a regular pattern here. The green area across the top is the CPU idle value, and as the CPU idle value drops, all of a sudden it jumps back up. It's happening very regularly like this because I'm just sending synthetic traffic to this machine. It's not happening in the chaotic way that you might see this for a public environment. If I switch this to the now graph, I just click on this little tab up here, it becomes even more apparent what's happening. When the user requests ramp up and my idle value drops, as you see right here, we hit that particular trigger point that I just described a moment ago. And that's when more servers get provisioned, and all of a sudden I have more idle capacity. Not because traffic stopped coming in, but because we noticed that the environment was becoming busy and we provisioned more server capacity at that moment. So let me describe a different type of scaling. We call this alert-based scaling because it's driven by the alerts that you defined that explain when your server is busy. But let me talk about a different type of scaling. Oops, where am I? I need this tab. That we call job-based scaling. I'm moving into the second part of the demo here, adding more servers based on a batch of jobs that is waiting to be processed. So for example, let's say you were transcoding a lot of videos. You had them all in QuickTime format and you want to transcode them to Flash. Maybe you're putting it on your website and you're pushing a Flash video on that. What's interesting about these jobs is that each one is independent and unique, meaning you can do them simultaneously. You can parallelize them, as they say. So in this logical diagram, I'm showing you how using the scaling capability, you don't need to wait for each job to be done sequentially. If they're all identical, meaning the digital transformation that is going to take place, you can simultaneously do it. So you can have a particular server that's got the programming, the application that translates from one to the other, and they just look at jobs waiting in a queue. And as jobs wait there, they grab them, they translate them, they put them in an output queue. Now, this is incredibly simple to set up rather massive batch processing jobs, and let me show you how that works. I'm going back to the deployment that I showed you a moment ago, but if I scroll down a little bit, we have this section called arrays, and have an array meaning a collection of servers that can scale based on this batch processing that they're waiting to, that they're monitoring for the queue, the grid workers that I show here. And if I flip over to the configuration page for this, once again, I just opened the tab. I have here my server array for grid workers. And if I scroll down, I know there's a lot going on this screen. So let's just monitor what's important for this explanation. How you configure how this queue is supposed to grow and shrink depending on the jobs waiting for it. And that's defined as what we call an elasticity function. And it's very simple. We just talk about how old is this item in this queue. And I can tell it, if there's any item that's been waiting there longer than 3 minutes, this is in seconds, 180 seconds, 3 minutes, then provision 4 more servers for me. That way, I don't have an infinitely growing queue. As more and more people are maybe submitting videos to my website, I can auto-provision more resources to keep up with them as they go. Or it could be any kind of batch processing. It doesn't need to be that specifically.
So it might be, for example, from this earlier slide, Swing Media transcoding videos.
Correct. Or it could be Eli Lilly that's analyzing how protein molecules fit with each other via a very complex calculation, and they can set up a lot of servers simultaneously to do all that.
So just one quick question on this. Is it, apparently you could run one server for a long time or a lot of servers for a short time. Is there any cost differential there?
Yeah, that's one of the really big benefits of the cloud. One server for 24 hours costs the same as 24 servers for 1 hour. So there's no savings in waiting a whole day to complete something that you could have done in just 1 hour. If you got 24 videos to transcode and each one took an hour, you could do them all simultaneously and be done as opposed to waiting for that at the same computational cost. And I'm sure there's a lot of business benefits that go along with that. I'm going to go back to the deployment that I keep showing here, and I want to point out that we have a lot of these pre-configured components. Michael was talking about different languages before. Notice that each of my servers have nicknames to them so that I can easily identify what it's meant for what. And they're based on particular server templates. That means that you don't need to build things from scratch. We have a library with server templates for .NET, for PHP, for Ruby, for Python, things like Apache and MySQL that are pre-built and pre-configured. But as I was talking earlier, when I was contrasting infrastructure as a service and the other types of cloud computing, these are just servers that you can, so to speak, pop the hood and start changing configurations. So you still have complete control and root access over all these machines, even though we have all this automation that I've been showing you. So I'm going to go into one more use case here, which is the dev and test that Michael mentioned. So imagine that you have a simple 3-tier architecture, load balancer, app server, database that you might use in your integration environment. And anybody that's worked on QA knows how painful and time-consuming that can be to just set up the one integration testing environment for your QA team to work on. And then once you do, it's difficult to keep it in that baseline of being identical to what production is going to be eventually. Here in RightScale, we have the ability to record not just the configuration of a single machine, but of a complete environment, and that's what I'm going to show you right now. We have what we call macros, which is recreating a whole, what we call a deployment, a collection of servers. So I'm going to run one right now to show you exactly how that comes together. So I have one here. That's my IBM WebSphere and DB2 stack. And again, it's a load balancer, app servers, databases. And I'm going to just execute this macro right now. For brevity, what I'm going to do is just select all the default values here. But I'll point out that you can actually pass parameters into the macro before it runs so that I can choose things like, am I setting this environment in Asia, Europe, or North America? Am I doing it with this particular application configuration or a different one? I'm just going to click Run right here. I need to give it a particular deployment, and I'm going to call it Webinar Demo for Dev and Test. And I click OK. Now, while this is executing, I'd like to remind everybody, imagine how long it took before to stand up not a server, but a whole collection of servers that are configured to work with each other. This is done. I mean, it took less to complete that than it took me to say it. So I now have a complete integration environment. As I ran that, RightScale just takes me back to my list of all the macros that I have for this account. So what I have to do here is open up a new tab, go back into RightScale. So I have a little save tab here. And as I log into RightScale, it shows me a collection of all my servers. That's kind of the default first view. And if I scroll down, you see the webinar demo for dev and test that I just created. I went kind of quick through that. I apologize if somebody didn't catch it. I then clicked on it, and you have what you just saw me build, a three-tier architecture. The load balancer, then the servers for the application servers in the array, so they can scale based on load, and then the database there. Now, I want to remind everybody again, this took mere moments as opposed to hours and days and sometimes longer that it takes to do this. And the other interesting thing here is that these servers are not quite running yet. I didn't launch them. I could launch them individually by clicking on the blue button here. And therefore, they're not really costing anything because I haven't launched them yet. If I go back to my running deployment that I've been using for all the examples, notice that I even have visibility into how much things are costing. This is costing 60 cents an hour or roughly $14 a day. So you have visibility into that. I go back to my webinar, my webinar demo for dev and test. It's not really costing anything yet. Now, one last hypothetical scenario here. Let's say I had 2 or 3 different QA teams, or one QA team that had to run 3 different regression tests or unit testing things. I can actually just simply clone this environment 3 times. Maybe I tweaked it already, so the clone, the macro would not build me the same environment. I just want to clone exactly what I'm looking at right now. I have a little button here, clone. And once again, as quick as I can just about say it, I have a brand new environment already built. And I would rename this one for a different team, and I'm going to call it for the blue team. And then I can ask the blue team to log into the RightScale account and perform the QA testing that they do for this particular deployment. Once again, I began with the idea of being able to group your servers into deployments for better visibility and control and abstraction between them. And you could, in fact, give people access to only certain things if that's something that you would want to do in your business practices.
You know, a question just came in, Yuri, that I think is worth addressing right here for a second. Somebody asked, the servers Yuri is talking about now, are they physical servers or virtual instances? And one thing I'd like to point out is what we're talking about here, and the reason that you can see these definitions of servers, server templates, and then you either have the red square or the green circle showing whether that server is running, is that there's a very critical and powerful distinction here between a definition of a server, which is a server template, which is a template, if you will, or a prototype of how a server should run, and the actual running server. One way to think about it in a simple analogy is if you think about, for example, music in iTunes. It's the difference between having a playlist where you can define what you want to play and then actually having the song itself that may or may not be playing. So it's a very powerful concept. It's a very flexible concept for how to dynamically configure servers. And that's how you should think about what Yuri's showing here.
And if I can add something here, Michael, before you go to the next question, think about it the following way. RightScale, in this regard, is a configuration database of all your servers and their specific configurations. So when you want to stand up a specific server with a specific configuration in a cloud provider's infrastructure as a service offering, what we do is we make an API call, stand up a server, and configure on the fly for what it needs to be. So RightScale is your orchestration layer in front of and on top of those physical servers. RightScale is only providing the software that makes it easier for you to manage all those things, not the actual infrastructure itself.
Right, exactly. And another point is around the collection of cloud-ready templates and deployments that we provide to get started with. So one question came in, I have only moderate Ubuntu skills. Is there a faster or easier method to create cloud units? I think he means cloud servers.
If you want, I can speak to it. Fact and point, or point and fact rather, I said that backwards. We have a library of pre-configured, an Apache server, a MySQL server, a PHP server, so that you don't need to be an expert at configuring everything from scratch. You don't need to reinvent the wheel each time. In the case of MySQL, we even have the master-slave database configuration in place so that they will synchronize out of the box. You basically need to make each server aware of the other one so they know how to synchronize, and they're good to go. So I said in the beginning, we take care of a lot of the heavy lifting without you having to compromise on having complete control over all the minutiae and technical details and configurations you might want to change. That's an example of that.
Right, and just one more comment in relation to questions that have come in. Number of questions around support for Windows. It's true that probably the Linux variants were supported first in the cloud in terms of the evolution of the cloud, but we just announced general availability of our complete support for Windows earlier in August, and so Windows is fully supported, ASP.NET. Another question about Oracle, so a number of different databases, etc. It's really quite an open, flexible environment. So if you have a particular component or middleware that you want to run, certainly give us a call and we'll tell you whether we already support it or how difficult it would be to move it to the cloud.
Let me jump in here with a question, Michael. I have one from earlier. Does the Hewlett-Packard 3-PAR merger affect your plans? I'm actually not sure where that ended up because I know there was a bidding battle there. It doesn't, in that we're all about managing that infrastructure. So the more players with better infrastructure as a service offerings, the happier we are, and if that means better storage available for the different types of clouds people want to build in their own data centers, we think that's fantastic news.
That's right. We're really neutral, to answer another question, neutral in regard to the different cloud infrastructure providers.
Yeah.
So before we go on to the full Q&A session, I think we have a couple more slides just to highlight what Yuri was saying about the cost tracking that you see here. You can see that this is a great tool for keeping track of how much you're spending. And then if we go back to the slides for a moment, wanted to wrap up by returning to the question of how you can promote this as an alternative inside your company. So one resource that we have, here's the URL to a full white paper written about total cost of ownership of using the cloud. So it's an analysis we did through interviews with customers of what are the benefits of using RightScale specifically over trying to piece together your own solution in the cloud using raw cloud APIs or simple consoles. And what we discovered is kind of two different categories of savings. The first one is around what it takes to get up and running initially. So you see that black box around initial deployment, really quite substantial savings, 67 to 85% in the cost and time required to get up and running. And then also, almost any application has a life cycle, right? You develop it, you test it, you roll it out, it reaches maturity, and then there's an end of life usually at some time. And there's maintenance, there's ongoing maintenance as time goes on. RightScale is very effective in reducing the time and cost of that ongoing maintenance. So that's what you see in those 50% efficiency gains, the later red curves. So that's one tool that you can use, is that white paper. And then I also wanted to give a sneak peek about an ROI calculator that we will soon release. And let me actually go to the website there and show you what that looks like. Here we are. This will be released in the near future. And what I've done here is, of course, put in a fictitious customer at RightScale. But what this will allow you to do is put in how many compute units defined as about a 1 gigahertz core, 2 gigabyte memory, etc. How many units you think you might need, how much storage, and then some characteristics around what kind of demand for the service you think you might get. Is it constant load? Is it unpredictable burst, for example? What low-level cloud you're running on, which hypervisor, which OS. Those are in relation to hypervisors and OSs that have costs attached or not. And once you enter all this in, over on the right side, there's some really compelling numbers that you can use internally to help promote what you're trying to do. So here I put in an example of 8 servers. Let's imagine that you were creating a website along the lines of what Yuri showed earlier, and you have one set of 4 servers for development and test and another set for production. So 8 server environment. I changed the default data storage. I took it down a little to 500 gigs. I specified 200 gigabytes of mountable fast storage, picked a number for inbound and outbound bandwidth. And what you see over here is a couple of very compelling statistics. One is the savings in upfront costs. And while that might seem a little large, this isn't just the cost of the servers. This includes networking costs to set up. It includes the cost of maintenance over time. And it includes data center power and some other characteristics like that that are folded into the true cost of setting up new capacity. It talks about an increase in your server utilization, which is really around efficiency and saving money also. And then if you come down to the Why RightScale section, this will tell you that by using RightScale, you can save on average $56,000 a year by using a managed cloud system. So there's a lot more detail to this, and when we release it, we'd invite you to have a go at it and give us your feedback. If you're desperate for something like this because you have a cloud project you want to get released right away, please contact our sales folks at sales@rightscale.com or the 800 number you'll see later and give us a call and we can help you. We've, of course, been working on this for a long time, so there's a lot of texture and I'd say richness to the calculations behind it. We're happy to share that because having worked in the cloud for 3 years, we've witnessed over and over again the cost and agility benefits that can be delivered. And some of those are mentioned here under agility. How much time do you save in provisioning and how much time do you save in reduction in administration hours? So with that, I think we'll wrap up the presentation portion of the session and allow you some time to fire away with questions over the Q&A channel. And Yuri, do you have some of those already?
I got one right here, Michael, so let me jump right in. I'm going to read the question first. You mentioned the autoscale. How reliable is it and how is availability handled? Let me mention, I don't know that we can name names. We have lots of customers that are using the scaling mechanism that I described for environments that have millions and sometimes tens of millions of daily visitors to their servers. So it is absolutely reliable. We have customers that launch a Facebook app, Facebook game, and they started running 30 servers, and over the weekend scales to 3,500 servers. So it's not something that's a brand new or a leading edge technology, by the way. It's something we've been doing for years. It's now getting a lot of interest because cloud computing is getting so much momentum, but it's something that's quite proven. The other part of the question was, how is availability handled? You can choose to scale those servers across what's called availability zones or regions, meaning you can provision them across different data centers so that you are geographically redundant as you add those servers and you're scaling up. Now, that takes some good systems architecture to do it properly, but it's something that quite a few customers are doing well.
Excellent. Here's another question that came in. How do you handle SLA issues, which really is short for Service Level Agreement, with Amazon Web Services? I see Eli Lilly is highlighted. Is that something between them and the provider, meaning the customer and the provider? Well, in part, yes. At the end of the day, our customers choose an infrastructure provider. The choice is really theirs. We don't heavily recommend one or another. We're happy to talk with you based on your needs of what features and capabilities might be more appropriate among the different offerings. So we're happy to share that, but we really don't recommend anything. So when you do end up choosing a provider, you do have a contractual relationship with that provider to use their infrastructure. And whatever contract terms are provided govern the underlying infrastructure SLA. RightScale itself also provides a legal contract or agreement with you, and we have our own SLA because for most of our customers, they don't interface directly with the infrastructure provider. They interface with RightScale. So RightScale, as Yuri mentioned, is the orchestration layer. It's the interface layer that you work with to manage all your resources. So we also provide a guarantee and an SLA in terms of our uptime and responsiveness.
Let me read the next question here, Michael. You make it seem so easy, but how much coding goes up front? Let me say, by the nature of the time restrictions in the webinar, I do have to go fast during the demos. I don't mean to gloss over things.
Way to make it seem easy, Yuri. Nice.
But what we do here is we put our best foot forward. Anybody can sign up for the free edition of RightScale and try this out. And it's not time limited. There's some features that we do ask you to pay for before they're available, but you really want to try out some of the things that I'm describing. Sign up for a free account. There's tons of documentation at support.rightscale.com, and you can put into practice some of the things that you saw me doing today. Obviously, I couldn't get into all the gory details of how to set up everything, but anybody that's worked in operations before and set these things up, you will see it is so dramatic, the time savings and the ease that it brings to the table.
Yep. Well, let me fire a question at you, Yuri. Here's a more technical question. What are the tools you provide for backup and restore and kind of the redundancy of information, data storage?
So we're able to leverage a lot of the capabilities that are built into, in the examples I've been using here for the demo, Amazon's Elastic Compute Cloud. So I'll use an example of a database. In the MySQL Manager, that's what we call the master-slave database server templates that we make available. It's interesting because in the cloud, everything's transient. Virtual servers come and go. The storage associated with them also disappears. And it's interesting that you can mount a virtual volume to a virtual server, and that virtual volume then becomes independent of the virtual server. And there's a lot of interesting things you can do because of that. We're able to, for example, snapshot those virtual volumes on a regular basis. So what backup capabilities do we provide? If I may get a little bit technical here, if you're building an environment on EC2 and you're attaching EBS volumes, we provide a set of scripts that we call the EBS toolbox to more easily, without you having to reinvent the wheel and program anything, attach an EBS volume, a set of striped EBS volumes that you can more quickly do I/O operations throughout, and then a mechanism for snapshotting those more easily, and then remounting off of those particular backups / snapshots. I know it gets a little bit more technical as you get into those, but for the person asking that question, I would encourage you to call into RightScale or send us an email, and we're more than happy to get into all the specifics of that with you.
Yep, that's a great answer. I would just add to that really the levels of redundancy and resiliency provided through cloud infrastructure are unprecedented, how great they are, how powerful they are in relation to cost.
Yeah.
So the super redundancy of S3, same with EBS, RAID level redundancy, and the layering of those on top of each other really gives you a pretty bulletproof data security.
Yeah, and if I might move it up beyond just data backups, for an incredibly low price, you can build a geographically redundant website on enterprise class infrastructure, and you're paying dollars an hour for these kind of things that used to take many millions to build that yourself in your own physical plant. I got another question here, Michael. It's also a little bit more technical, but I want to address it. How easily can you migrate virtual machines between providers, or from an on-premise cloud to a public cloud or private external provider? Again, the demos were not meant to be very deep technically. What we have is this technology called server templates, in which we have a small number of virtual machines, essentially just a basic operating system when you stand up a virtual server. And the server templates that you keep here talking about is what actually builds your machine. Think of it as a recipe that will build it to be a web server, a database server, an app server, depending on what it needs to be. And that's the power of a lot of the RightScale things that we're discussing here, is that the logic of what the machine is going to be is built on that server template, even if the virtual machine stays the same, meaning I have a virtual machine with Ubuntu and a virtual machine with CentOS, but the real logic of the configuration of the Apache web server or the MySQL database is built on the server template, an abstraction layer above that. And that's what makes it possible to move it either between regions of Amazon as one example, or from a provider to another, or from a public to a private cloud. Now this gets very much into the specifically what exactly do you want to do, but it's something that we address.
Great. Here's another question on what's probably one of the biggest concerns that we get about cloud. It's around security. So we all hear a lot about, is the cloud secure, etc. The question reads, we process sensitive HR data on our own hardware in data centers. when using the cloud, how can we and our clients be sure that nobody can access the data when using infrastructure in the cloud? So, I guess the quick answer I'd give you and then point you in a direction for further resources. The quick answer is there are many aspects to the question of security in the cloud, but the major ones are, on the one side, sort of technically, is your data and secure, and the second part is trust. So any company that, for example, uses an external payroll provider to handle their payroll and paychecks and so on is already familiar with the notion of trust in terms of very private data being entrusted to a third party. And many, many companies do that. So from another industry example, most of us are used to that. So when we move over to the cloud, one shift that we need to make is from the notion that security needs to be location-based to the notion that security needs to be process-based. And you need to look at it in layers, everything from the transmission of data, how is it stored once it's in the cloud, who has access to it, what kinds of security and regulatory compliance is the cloud infrastructure vendor certified for, and so on. But there are really, really top-notch offerings that offer a very high level of security in the cloud. And I would point you to, for example, a webinar that we did earlier this year in cooperation with two other vendors. I think it was Amazon and HyperStratus. There's a recorded version of that up on our website where we spend an entire webinar delving into security and how you can achieve that using cloud.
So I got a question here about test and dev, Michael. Does one, meaning what area network, does one latency between the test team and the service located in the cloud get in the way of doing work? This is one of those, it depends, but we've never seen it be an issue. You're usually not uploading massive amounts of data for this kind of test that you may be performing. So in fact, it makes it a lot easier. I know in the past, large companies will literally purchase hardware to send to a testing company in another country, a consulting company that they're engaging with. In the cloud, you're just sending up the resources. And the traffic for the testing back and forth is mostly just remote control of the servers themselves, not any kind of massive data test. So the short answer is not usually an issue.
Okay, and just a couple of quick ones here with quick answers. One is, can we use RightScale for scientific projects? Answer is yes. Can we use MapReduce and Hadoop in RightScale? Answer is also yes. There.
Cool, guys. This is Sarah. I'm just going to jump in real quick. We want to be respectful of people's time. We're just on the hour right now, but there are a lot of really good questions coming in over the questions line. I think we'll take one or two more, so feel free to continue asking your questions. Michael and Yuri, if you have one or two more, let's go ahead and address those.
So I'll take the, can you tell us about RightScripts question? You heard me talk about server templates a moment ago. And server templates are really built on this concept of RightScripts. Think of an Amazon machine instance, what they call it a virtual machine in VMware. It's one big file that defines a whole server. A server template is built on RightScripts, and a server template is a virtual machine, but in our case, we only put the operating system on it, just CentOS, just Ubuntu, just enough to boot, by the way. And once it boots, RightScripts will install Apache, install MySQL, install additional tools, make configuration changes. Think of it as a recipe that builds a server for what it needs to be, that particular instantiation. And that's where this tremendous flexibility comes. Also operational efficiencies. I'm not maintaining a lot of different images with a lot of different security patches that I need to worry about. We have one customer with 12,000 servers and just one image. Lots of server templates, but just one image to maintain. And the other advantage is what I described before of the ability to then take that image, let's say Ubuntu, replace it with CentOS, and maybe moving it to a different cloud provider. And the other really interesting thing about the RightScripts is that you can pass values into them as you stand up the servers. You saw me doing a little bit of that doing the macros, even though it's not exactly the same thing. But when I stand up my MySQL database, I literally pick from a drop-down menu, do I want it to be the slave or the master? And then the RightScripts will configure it accordingly.
Just one added word to that. You don't need to be scared of scripts, and you also don't need to write them all. They have a huge library of as we say, pre-built templates, each of which contains numerous scripts that you can start from.
Yeah.
But the key advantage is if you need to change something under the hood, as you said, you can.
Yeah.
So last question on my part was around pricing. Someone asked, how is RightScale priced? RightScale is priced, if you think of an analogy, somewhat like a cell phone plan or mobile phone. We have a variety of editions which contain various features for how many users and accounts, various capabilities across auto-scaling and user authentication, etc., that we've reviewed today. It's all up on our website. And the base fee covers the capability to access those features and usually a bucket of hours of servers managed. And then if you exceed that bucket of server hours under management, you pay as you go. So you can think of it as a usage-based scheme with a base or a floor cost.
Very good. Thank you, Michael. Thank you, Yuri. And with that, we're going to end the audio portion of our webinar. There's still a lot of questions coming in over the questions panel. I know that Andy and Bryce are firing away at answers to those questions, and I don't think that their fingers are cramped yet. So go ahead, continue asking those, and they'll continue answering as long as people are online. We have recorded this webinar just like we record all of our webinars. It'll be posted in the next 24 hours. We'll email it to everyone, but in the meantime, if you'd like to check out our whole library of webinars, they're on RightScale.com. Just go to the Cloud Resources section and look for webinars. And with that, we'll sign out for today. Thanks for coming.